There we go. Okay. So our formula was we had two versions. Okay, so we're going to end up with one of these two, and then we know that they're essentially the same, so if we have one, we have both. And it's just a clever trick that we use in order to prove this formula, so this wouldn't be something that, for example, you'd be expected to come up with and invent on an exam, but it's just a cool thing to see. So, here's our geometric series. Oops, not one. We've got our first term. And our second term, to get there, we just multiply by r. So our second term is u1 times r. u1 times r squared as we multiply by another r. We're using our geometric sequence formula here, bless you. And if we have n of these things, then the last one's going to be, I'll do 2 here. The very last one is to the n minus 1, so the one before it is to the n minus 2. Why? Which part? The n minus 1? Instead of... Is your question why is it not just to the n? Do you think you figured it out? Yeah, can you remind us again? And then we're doing the same thing here. Okay, now we're trying to figure out what this value is. We don't know what it is, so let's call it Sn. Now what we're going to do is take both sides of this equation and multiply them by the common ratio. I'm going to write that underneath. So on the left, ratio times the sum. And on the right, I'm going to multiply each of the terms by the ratio. But I'm going to write it a little differently. So this u1 here, I'm going to multiply him by r, and then he kind of matches the second term above, so I'm going to write him underneath. And now I'm just going to shift over 1. So multiply this guy by r, multiply this guy by r, we'll have u1 r squared. And we keep doing that. So we'll get a u1 minus 2. This guy will be multiplying this r to the n minus 2 by an r will give us r to the n minus 1. And our last term, everybody? What? u1r, what is it? Just to the n. Oh, just n. Okay. So now it looks like we've just made things more complicated. But since we have two equations here, just like when we have a system of equations, we can subtract the right sides of an equation and the left sides of two equations, and we'll get something that's still equal. So we're going to subtract the bottom from the top, which means to the left of the equal sign, we'll have the sum minus r times the sum. Okay, and then here, u1 is still there, u1 minus nothing. But then notice u1 times r is going to cancel with the other u1 times r. Same thing's going to happen here. Same thing's going to happen here, and here, and here. So we're going to cancel, 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 all the way to the last term, because there was no r to the n term up top. So we've got 0, 0, 0, 0, 0, and then we've got minus a u1 r to the n. And that's the weird part. But it's also improved things because now we have only two terms on each side. And And remember, our goal was to try to find a formula for the sum of n terms. So we're going to solve this now for that Sn. Oh. Now we're getting dangerous. Playing with the controls. All right, well, we have two sum of n terms here, so I'm going to factor that out with the left side. So factor it out of the Sn, that leaves 1, and then there'll be a minus r here. And then to clean up the right-hand side, I see that I have a u1 in both terms, so I'm going to factor that out. And now our goal is to isolate the sum, so we'll divide by the 1 minus r. Do the same thing to the other side. And here appears our formula for the sum of n terms.
What are the dot 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 and zeros?
Zeros?
Oh, cancel.
Yeah, that we canceled, like here we got 0, here we got 0.
Right.
Everything canceled except the first term of the top sequence and the last term of the bottom series. Other immediate questions? Okay, so here's what I'd like you to do. See if you can turn to the person next to you and have one of you explain to the other person what just happened there. How did we end up solving for the sum of n terms? If you discover other questions, talk it out with your group or let me know. And then once you're happy with that, go ahead and get started on the problems for the homework. Go for it, explain.